Today we will discuss derivative. Last day which I have discussed the basic ideas. Today I will be discussing the next portion, that is differentiation of function, and this rule we call as chain rule. What is chain rule? Actually, if we write dy dx as dy dt into dt dx. Why I will write this, I'll explain, but the point is, if we write like this, then dt cancelled out and dy dx will be the answer. Now this idea will apply. When we'll apply this idea? When if y is a function of a variable t, or t is a variable, and here t is a function of x. So what is we are observing? What we are observing? We'll apply this principle, this chain rule principle, in the case of function of function. Actually, if you watch this concept, y is function of a variable t and t is a function of x. So in the ultimate sense, y is actually function of x. T is just connecting y with x. So we'll solve the problem by differentiating y in terms of t and then t in terms of x. That means we will differentiate y with t. This we denote by f dash t, and we will differentiate t in terms of x. We denote it g dash x, and then we will multiply these two to get the required derivative of dy dx. This is the concept. Now let us take the example, this chain rule, how we will apply. This will be applied in the case like differentiate log x square plus 1 with respect to x. In this case, if I write y is log x square plus 1, then what we are finding that y is not directly linked to x. It is linked to x square plus 1. That means y is function of log. Log is function of x square plus 1. So if we write here, we can write y is log t. And what is t? We are assuming that t is a function actually directly with x. So what is happening? Y is linked to t and t is linked to x. Then what is the concept? We have to find out dy dx as per question. We will find dy dt first, that is the derivative of log t, which is 1 by t. We know that log t derivative is 1 by t. And dt dx. Why dt dx? Because t is linked to x, that is t is function of x. So we will find out dt dx, that will be x square derivative is 2x and 1 is 0. So what is happening? We are trying to find out dy dx, and dy dx will be dy dt into dt dx as per chain rule we have discussed just before. So the result dy dx will be dy dt into dt dx, and that means dy dt is 1 by t, dt dx is 2x, and answer we are finding as 2x by t. Now what is t? T we have assumed x square plus 1, so 2x by x square plus 1 is the answer. So this is the concept of chain rule, which we can write directly by thinking a little bit, that whenever we are differentiating any function, like another example we can take. Here y is differentiate root over 2x cube plus 1 with respect to x. So it is actually not exactly similar because it is not log. So we'll write let y is equal to 2x cube plus 1 to the power half, because root is half. Now if we watch this, 2x cube plus 1 is converted to t, if I, then it will be y is t to the power half, and t is now 2x cube plus 1. Therefore we will differentiate dy dt, not dy dx directly, because y is not linked to x in this case, because we have assumed this portion that 2x cube plus 1 as t, so it will be half t to the power half minus 1, which is minus half, which is 1 by 2 root t, because t to the power minus half is root t in the denominator. And in the other part, dt dx will be 6x square. So we have found dy dt as part of the function t, and when we are seeing the part of t with x, dt dx is 6x square. And as per chain rule, we are finding dy dx is dy dt into dt dx, and the final result we are finding from here as 1 by 2 root t, which is dy dt we have found, and dx dt is dt dx. dt dx is 6x square. So finally our answer will be, now t is already taken 2x cube plus 1, and this is 6x. 6x means 6 and 2 cancelled, 3x square, 6x square, 3x square by root over 2x cube plus 1. So this is the concept of differentiation with the help of chain rule. Now this type of problems, these problems can be applied to another type, that is called parametric form. The next idea of differentiation is parametric form. And what is parametric form? Parametric form is the next concept of differentiation which we need. If y is function of t, t is a different variable, not linked to x, and x is linked, but it is another function of t. So here what I am finding, this is not chain rule exactly directly, but y is depending on t, function of t, and x is a function of t. Both are depending with the variable t. In the previous case, y was function of t and t was function of x, but here we are writing y is function of t and x is also function of t, and we are wanting to find out dy dx. What we can do? We can do the same way, dy dt into dt dx. The same method, chain rule. Let us try to explain this way. Dy dt will be dy dt, and the dt dx will be 1 by dx dt. That means we can reverse the concept of dx dt in this way. So what is the result? What we can find? Differentiate or find dy dx. Better the question will be find dy dx. Find dy dx. Y is equal to, where y is equal to a t cube and x is equal to 2at square. So this is the question. Now what will be our method? We will solve it in this manner, because x and y are this is parametrically given. Parametrically means it is depending on, both are depending, y and x are both depending with t, but the t is a different variable from y and x. So what we'll do, we'll first find dy dt. dy dt means 3a t square, because a t cube, when we are differentiating, 3 will come and t square, and when we are finding dx dt, then we'll see 4a t. So we have found dy dt and dx dt. Our target is to find out dy dx. What we'll do, what we'll be doing, dy dx is dy dt into 1 by dx dt. When dy dt is 3at square into 1 by dx dt, that means 1 by 4at. The idea is dy dt into, this is a chain rule, into 1 by dx dt. That means 4a, this a is cancelled and t square t is cancelled, so 3t by 4. This is the answer for this one. So it is parametric, because in the answer you are finding that t is present in the final answer. T is the parameter. So this is a parametric differentiation. The question will be like this. Now the next one is implicit form. Implicit form means when the derivative we need to differentiate, but the question is y cannot be separated. That means if I differentiate function of y, what will do? Derivative of function of y with respect to x. We are differentiating the function y, but the function y will be differentiated with x. Derivative of function of y with respect to x. So what we will do? We will differentiate y, that is f dash y, the function of y, but into the chain rule dy dx. Why chain rule? Because this portion is differentiated with y, and the next part will be multiplied with dy dx. So whenever the implicit idea, when the idea is implicit, means you cannot separate out y from x. Y and x are such a way given that we cannot separate y as a function of x. We cannot separate y as a function of x. like find dy dx. Question is find dy dx where the equation type y square plus 3y is equal to 2x square plus 1. You have to find dy dx. What is the problem? That y square plus 3y, in this case y and y both are in a functional concept, and that side is also a function of x. So this is a function of y, this is a function of x. How to find out the derivative? We will just differentiate directly. We will differentiate directly. That means y square derivative is 2y, but this into dy dx. That is the implicit part. That means when you differentiate y any form, y square, y cube, yeah, log y or log y, anything, then you will be differentiated that f dash y, that y square is derivative is 2y, but you have to multiply a dy dx. Next is 3y is 3 because y derivative is 1 into dy dx. This is the left side differentiation. Why differentiation requires dy dx? Because you cannot separate y as y is equal to a function of x. Y is not equal to directly function of x. This is y square plus 3y. That means this is a function itself in terms of y. So we differentiate and multiply dy dx. On the other side, this is 4x plus 0 because one derivative is 0. So what is happening? 2y plus 3, you will take dy dx common, is equal to 4x. So final answer we are getting in terms of y and x both, sometime only y. That means the result will be, dy dx will be in terms of y. That is 4x by 2y plus 3 will be answered. In this answer you are finding that y is also present in the final answer. This is the idea of implicit form. Now the last type of problems which we usually see, that is variable to the power variable. Means the power is also a function of x and the base is also function of x. So we have to take log and then differentiate. Take log on both sides. You have to take log on both sides and to find out dy dx. And to find dy dx. This is a function, this is we can consider, this is logarithmic differentiation. Log differentiation also we can say. Log differentiation. Log differentiation is required when you have function of the power is also with the function of x. So take an example, differentiate x to the power x 2x. Differentiate x to the power 2x with respect to x. So in this problem, let y is equal to x to the power x. Then we'll take log on both sides. Why? Because this power is also x, the base is also x. If you take log on both sides, then what is happening? Log on this idea. So the power will come before. So log y is now 2x log x. So it is your question. The left side you are finding a function of y, log y. And the right hand side you are finding 2x log x. So that is a function of x part. So it is implicit form. Left side is function of y. It is not only y. If it be only y is equal to 2x log x, then it can be simply differentiated, but it's log y. So we are differentiating. Log y derivative is 1 by y. And implicit required dy dx. On the right hand side is a product rule. Last day we have discussed the product rule. Log x into derivative of 2x is 2 plus 2x into derivative of log x is 1 by x. We have discussed last time that uv 2x derivative is 2 and log x derivative is 1 by x. So x cancelled out. Therefore our answer is 1 by y dy dx is equal to 2 log x plus 2. Now our final answer will be dy dx is equal to y into, y is taken from this side to that side, 2 log x plus 2, and what is y? We have assumed it, x to the power 2x, 2 common, log x plus 1. This is the answer for this logarithmic differentiation. So that is, these are the basic ideas of, these are the main parts of derivative. Last day I have discussed the basic ideas of derivative. Today I have given you the ideas of differentiation in other forms. That's all for differentiation, what we need to do in normal examples.